2, which is very quick, but I want to talk about briefly. Data cleaning steps in order. I came up with this. It's so far working pretty well for me. I came up with this based on papers that have been retracted or corrected and what they did wrong. Would love your guys' feedback. So I have a recommended order of data cleaning. It's the CLEANR, if it helps you think of it. Compiling, labeling and naming, examining, altering, creating new variables, and then reconfiguring and re-examining. Compiling. All of the data you need, none of the data you don't are available in your data set. So importing data, merging and appending, reshaping. If you don't know what reshaping is, it's just taking data that looks like this and making it like this. Just different ways of looking at your data. You would want to do that at the beginning. Labeling and renaming. You might want new names for your variables because they might have come really ugly from the data set. So rename them, label them, tell yourself what they are, label the values of those variables. You know, if you have a race variable, what does 5 mean? What does 4 mean? What are you up to? Encoding a variable is the process of changing a variable that's in words to a variable that's in numbers. So you might want to do that, but in R, you don't have to. So know your software, know what you're up to. And changing a variable type. So you might have integer variables or string variables, and these are all read differently by your software. So just think of these as different ways that your software reads your variables. And sometimes for different kinds of analyses, you need your software to read a variable in a certain way. So just know that and think about if that's going to affect you. So that's another reason why knowing your final analyses can help you in the data cleaning part. Examining, making sure your data makes sense, getting to know your data personally, looking for duplicates, looking for outliers, looking for range constraints, meaning, do you have somebody in your sample who's 150? Well, they need to be in the Guinness Book of World Records, or maybe they're 15 and they didn't mean to add a 0 to their thing. Something to think about. Descriptive statistics, meaning looking at means, medians, modes, all of that kind of stuff, just checking out what you have. And you can make notes of all of those issues in your data management appendix. Graphs are particularly helpful for examining, by the way, because sometimes looking at numbers doesn't always show what's going on. Altering is the next step. And this is recoding things, transforming, removing duplicates, addressing anomalous data, addressing missing data. And you don't want to alter your data until you know what you've got. So I'm going to talk about why the steps are in this order, but I want to focus on this really quickly. You can't start altering things until you know what you're working with. And if you are addressing missing data, you need to know why it's missing before you just start addressing it. So examining has to come before altering. Creating any new variables. So creating scales, if you have like a lot of different items that are part of a larger scale measure, so depression, and you have a bunch of questions and then their answer to all of them gives you a idea of how depressed they are. You can create those variables at this point once you've dealt with missing data and outliers and stuff, but you don't want to start creating scales before you know if people are missing on the variables. So something to think about. Also combining variables in substantive ways. One example of this might be BMI. If you have that height and weight, combining them in a substantive way to create a new variable. Then reconfiguring might be merging 2 different data sets together or reshaping again. And then re-examining, and this is the final step before you do any analysis. Just again, make sure that all of the changes you made make sense. Compare new variables against original variables, re-examine your missing data. What are you up to? And then this MAR, MCAR, and MNAR are all different forms of missing data, missing at random, missing completely at random, missing not at random. All of these words are different depending on what field you're in. Don't worry about it. Just has it changed your ideas about why data is missing and how it's missing? Why in this order? You first need to have your variables in your software before you label and name them, because again, you want to have a record of what you changed names to. So get them all in the software, get them together before you start labeling and renaming. You want to label and rename things before examining because you don't want to type really ugly words into your software longer than you have to, right? So name them in a way that's easy to use before you start looking at them. Label them so that if you're looking at relationships between something like gender and income, you know what gender you're looking at. Examine before altering, I talked about that, but if you're imputing data, you have to make sure that all of the assumptions that apply to a regression are good to go before you start doing the imputations. And so you need to actually look at your missing data before you even start doing imputation. So something to think about. We're going to skip that because we're running out of time. I thought I did so much better this time. Altering before creating new variables. You got to address missing data before you start creating scale variables. Reconfiguring later. Sometimes you need things to be clean before you start messing with it. These are caveats to all of this because nothing is super clear, which leads me to this. The applied researcher who routinely adopts a traditional procedure without giving thought to its associated assumptions may unwittingly be filling the literature with non-replicable results. And so I'm very cautious to be like, this is a general recommended order of cleaning because there are going to be changes to it, right? But if nothing else, this is helpful for you to know all of the kinds of steps that are involved and have some sort of an accounting for it, and then moving forward. But you're probably going to change them. So I often create binary indicator variables of missing this. So I'm creating a new variable before I'm examining all of the data. Okay, yeah, that makes sense. So some of this stuff is going to be a little bit different, but something to think about. Principles. Just make sure everything is labeled clearly, understand your data, make changes only after you know what you're up to, try to make changes only once, and then the last step is always going to be to re-examine. Conclusion, CLEANR. So, concluding the intro, data cleaning is not easy, but it's important, and the final goal is accurate and reproducible research. Best practices to get there, we want to plan ahead. We want to have transparency in our decisions. We want to document our decisions in a way that makes it easy for other people to follow what we're up to. We want to automate things so we're not changing it in a million different places. We want to get familiar with our data really intimately, and proceeding in groups can be helpful. And then CLEANR, compiling, labeling, examining, altering new variables, and reconfiguring and re-examining, I think is a really helpful way of kind of grouping these tasks together and thinking about the general order, especially because there's a lot of research that suggests that the E, A, and N done out of order are going to give you type 1 and or type 2 error. So just be really careful about knowing what you're doing before you're creating any new variables or altering your data set in any way. Make sure you know what you're up to. Thank you. Any questions, comments, concerns, things I needed to elaborate on? And then remember, there are like all sorts of appendices and like little tips and tricks and stuff that could be helpful. So I'll stop sharing. Oh, I'm glad you guys found it all helpful.
You have one question that came in via Twitter because I was live tweeting again.
Oh, okay.
Do you have any strategies you use to try to keep your students to do this consistently?
Yeah, so I guess the reason why I actually started doing this is I was told by a PI, clean the data. And I came in and I showed them cleanish data and they were like, well, did you do this thing? And I was like, no. And they were like, did you do that thing? No. Well, so I assign it step by step for them. Okay. And walk them through it. I teach them about the principles of workflow and like organization beforehand, and then say, okay, how about you go and you name all of the variables? So then they go through and they rename all of the variables. Okay, cool. Now, can you like examine them? Give me some tabulations, give me some figures, give me all of that stuff. They look at them. Okay, give me some more is normally the next thing. Okay, now we're going to alter. So I think it's really incumbent on the PI to walk the RAs through that process. And having some templates laid out for them that they can adopt. Yeah.
And I would imagine, especially at that re-examine stage, you're probably asking lots of questions, right? That's your chance to check and make sure that things seem to be making sense.
Both the examine and the re-examine are both where I'm like kind of hypercritical of, not of them, but of all like the data, right? These give me a good chance to really dig into it. And sometimes the person creating graphs and stuff doesn't have the mental capacity to look at them very critically. And so it's important for us who have had to step back from the data to use the brain, that space that was freed up by having a wonderful RA do stuff for us, to be able to look at it and say, oh, what's going on here with height, or, you know, whatever variable you have.